So now I'm going to give a complete explanation of the code which is based on MPI and OpenCL. This code is written in C++ language. So first, we have included various directives for standard input and output, standard library functions, time functions, timing functions, OpenCL library and MPI library respectively. Then this is an OpenCL kernel code for matrix multiplication on the GPU. It defines a function matrix underscore multiply that calculates the product of matrices A and B and stores the result in the matrix C. Then comes the function for matrix multiplication in the CPU. This function performs matrix multiplication on the CPU using nested loops. It calculates the dot product for each row of the matrix A with each column of matrix B and compute the corresponding element of matrix C. Then comes this complete function, which is the function for matrix multiplication on the GPU using OpenCL. In this function, it performs matrix multiplication on the GPU using OpenCL. It initializes OpenCL. Here, it has initialized the OpenCL and creates the memory buffers for matrices A, B, and C. Compiles in the OpenCL program and executes the kernel and reads the result back from the device memory. Then comes the main function. This is the main function where the MPI parallelization is managed. The program initializes MPI, broadcasts the matrix size from the root. Here, the broadcasting is done to all the processes, scatters matrix A among processes, performs the GPU multiplication, and gathers the results from all the processes to the root process and compares CPU and GPU results for verification. Finally, it cleans up the allocated memory and finalizes the MPI. Here, here the cleanup process is done and MPI finalization is done here. So now I'm going to explain the code that is based on MPI. First of all, there are libraries included in the code. These are the standard libraries that are used in the code. IOStream is standard for input-output operations like cout and cin. CSTD library is a standard C library that provides functions like random and srandom. CTime is a C library that works with time. Chrono is a C++ library for time measurement. MPI.h is MPI library for parallel computing. So then comes the function of the matrix multiplier. This is the function in which we perform matrix multiplication for a portion of rows, matrices A and B, and stores the result in matrix C. The matrices are of the size X. Then comes the int main function. Basically, in this line, this is the main function where the MPI parallel matrix multiplication is implemented. Then comes MPI initialization. This is the part where MPI initialization is done. So MPI underscore init initialize the MPI environment. MPI underscore com underscore rank gets the rank, basically the identifier of the current process, and the size one gives the total number of processes in the MPI communicator. Then comes matrix size input. So here, if the rank 0 is there, it means the master process is going on, prompts the user to enter the total size of the square matrices. Then comes the broadcasting. The total matrix size is broadcasted to all the processes here. Then comes the matrix initialization. This is the place matrix initialization and memory allocation is done. So, matrix size defines the total size of the matrix. Block size defines the size of the submatrix that each process will handle. A, B, and C are the pointers to the matrices A, B, and C respectively. Sub underscore A and sub underscore C are the pointers of the portion of matrices A and C that each process will handle. So if rank is double equals to 0, matrices A and B are initialized with random values using srand function and rand function. Then comes the scattering of the matrices. So scatter matrix helps to basically here matrix A is scattered to all the processes. Each process receives a portion of matrix based on block size. Then comes broadcasting the matrix. So matrix multiplication is performed on the local portion of matrix A, that is sub underscore A. Time taken for multiplication is measured using the chrono. Here, the matrix B is broadcasted to all the processes. Then comes the time of gathering the results. Result of all the processes are gathered to matrix C on rank 0. On rank 0, the elapsed time for matrix multiplication is printed. Then comes memory deallocation and MPI finalization. Memory allocated for matrices and submatrices is deallocated and the MPI environment is finalized. So basically, the code initializes two square matrices A and B with random values, splits matrix A into submatrices, perform matrix multiplication in parallel using MPI, gathers the results on rank 0 and prints the elapsed time. So this is the code of multi-threaded. In this code, basically two main new libraries are included, the thread and the vector library. The thread library is used for multi-threading and the vector library is used for dynamic arrays. Then comes the function of matrix multiply. This function performs matrix multiplication for a portion of rows of matrices A and B and stores the result in matrix C. The matrices are of the size X and the matrix multiplication is performed from the rows ranging from start underscore row and end underscore row. These are initialized here. Then comes the matrix size and number of threads. This is the part where matrix size and number of threads are basically prompted to enter the total size of the square matrix and the number of threads to be used for parallel execution. Then comes the part where matrix initialization and memory allocation is done. Dynamic memory is allocated for the matrices A, B, and C. Matrices A and B are initialized with random values. Then comes the part of multi-threaded matrix multiplication. This is the complete code for multi-threaded matrix multiplication. In this, start underscore time records the start time of matrix multiplication. Threads basically are the vector to store the thread objects. Chunk size is the size of the chunk, basically the portion of rows of the matrix that each thread will handle. Start underscore row is the starting row for each chunk of rows that a thread will handle. So basically, threads are created to perform matrix multiplication in parallel. The number of rows to be processed by each number of thread is calculated based on the chunk size. Threads are created using std thread and matrix multiply function. Threads are stored in threads vector. All the threads are joined to wait for them to finish their execution. The elapsed time of vector, the elapsed time of matrix multiplication is calculated and printed. Memory deallocation comes here. The dynamic memory allocated for matrices A, B, and C is deallocated. So, overall, in this code, the code initializes two square matrices A and B with random values, performs matrix multiplication using multithreading, calculates the elapsed time for matrix multiplication, and deallocates dynamic memory. The number of threads used for parallel execution is specified by the user. So, this is the code for sequential. First comes the function for matrix multiply. This function performs matrix multiplication for square matrices of size x size. It multiplies matrices A and B and stores the result in matrix C. Then comes the main function. This is the main function where matrix multiplication is implemented. Then comes matrix size input. The user is prompted to enter the total size, basically the number of rows and columns of the square matrices. In this part, matrix initialization and memory allocation is done. So here A, B and C are the pointers to matrices A, B and C respectively. Dynamic memory is allocated for matrices A, B and C based on matrix size entered by the user. Matrices A and B are initialized with random values using random functions. In this part of the code, matrix multiplication is done. Start underscore time records the start time of the matrix multiplication. Matrix underscore multiply calls the matrix multiply function to perform matrix multiplication. End underscore time records the end time of matrix multiplication. And elapsed underscore time calculates the elapsed time for the matrix multiplication. Then comes the print elapsed time. Here, the elapsed time for matrix multiplication is printed in seconds. Memory deallocation part is done here. The dynamic memory allocated for matrices A, B, and C is deallocated to prevent memory leaks. So, overall, the code initializes two square matrices A and B with random values, performs matrix multiplication using matrix multiply function, calculates the elapsed time for matrix multiplication, prints the elapsed time, and deallocates the dynamic memory used by the matrices. The size of the matrices is specified by the user.